Hello, and thank you for joining us. So, in this video, we're going to look at quick application of the factor and the remainder theorem, sometimes known together as Little Bezout's theorem. So, let's say I have a polynomial and I divide it by a linear expression x minus k, where k is a real number. The remainder is f of k. We call that the remainder theorem. If that remainder is 0, then x minus k is a factor. That's called the factor theorem. It is important to note that the remainder theorem, and by extension the factor theorem, require the divisor to be of the form x minus k when evaluating. So let's look at our situation here. We want to use the factor remainder theorems to determine if 2x minus 3 is a factor of either expression below. Right, so basically we're saying, is x equal 3 halves a root? Well, for the first one, we can say, well, if x equals 3 halves, we have 2 times 3 halves to the third power minus 3 halves to the second power minus 7 times 3 halves plus 6. So that's going to be 2 times 27 over 8 minus 9 over 4 minus 21 over 2. And looking at this, it seems like having a common denominator of 4 will be easiest. Oh, I don't know how I just erased that, but let's see if I can undo it. No. So I just erased something and not sure how that occurred. So let's just go back through and do the math again. So we got 2 times 3 halves to the third power minus 3 halves to the second power minus 7 times 3 halves plus 6. Right, we said that it was going to be best to have a denominator of 4 because this was going to then give us 27 over 4 minus 9 over 4 minus 21 times 2, so that would be minus 42 over 4 and then plus 24 over 4. So if I add these together, I get 0. So therefore, x equals 3 halves is a root, which then means 2x minus 3 is a factor. Okay. What about for this expression over here? Well, let's take the 3 halves, go to the third power, plus 2 times 3 halves to the second power, minus 3 halves, plus 4. All right, being proficient with our fractions will make life easier. So once again, here's 27 over 4, plus 2 times 9 over 4, minus 3 halves, excuse me, plus 4 over 4. If I look to this common denominator, or 4 over 4, that'd be 4 over 1. Common denominator of 4 seems to be best. But I could also look at these overall values and see I have a positive value here, I have a positive value here, minus 1/2, plus 4. So do I really need to evaluate this? Not necessarily, all right, but we'll go ahead and continue with this so that you see. So plus 18 over 4 minus 6 over 4 plus 16 over 4. So clearly that is not 0. So therefore x equals 3 halves is not a root, and by extension 2x minus 3 is not a factor. So that's using the factor theorem and the remainder theorem to determine if a linear factor is a factor of a particular expression that is a polynomial. Thank you very much for your time.